Okay, guys, let's get started. Last stream of the day today. Here's the link for those of you who are in the channel. Wrapping up the filtering work. I think it's good enough for the first iteration. Okay. Hello, Zach. Okay, first things first. It would be cool to see how many, in general, how many pairs does previous work use for per language pair? So how many pairs of translations to train a particular language pair, and how does that function? What's the function with the model size? So let's maybe start. Let me see. What's the best way to see this? I'm gonna check out a couple of papers from the literature page I have here. Okay. Hey Andy, thanks a lot, man. Thank you. Okay. Let's see. What's the amount of sentences they use for this paper? Training? 55 million. Number of words. Let's see what Chris mentioned in the Discord server. Roughly 100 billion tokens. Okay, I just see 50 million here in the training set. Is this focused only on Serbian or multiple languages? Let me quickly see the abstract. This work investigates blah 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 for translating English user reviews into Croatian and Serbian, two similar morphologically complex languages. Okay, I don't see a breakdown across the languages, I just see the number here in total. And what's the size of the model they've used? For each starter language, we selected the top 9 million sentence pairs, thus 18 million balanced sentence pairs in total. That's for the out-of-domain data. Table 1 shows number of sentences, running words, blah, blah, blah. Okay, I think we've seen that before. Model size. Parameters. No mention of the mod. Okay, they mentioned the 6 layers. This is probably even smaller than 600 million. Okay, this is not particularly useful. Model size. Okay, it was not popular to report the number of parameters back then, I guess. Let me ping a friend who might have a bit more information about this. Okay. Let's see what the NLLB paper used. Okay, if anybody knows, if you read the paper, or if you're willing to help on the stream, open this paper and let's try and find the number of sentences they've used per language pair. So given a language pair, how much data we need roughly, given a particular model size as well. Preparing the data. Table 52 might be interesting. Directions, languages. Okay, that does not contain the number of sentences. Filtering. Distribution of amount of training sentence pairs across the languages. We observe that the majority of pairs have fewer than 1 million. So that's 10 raised to the power of 6. Then they have 10 raised to the power of 7, which is 10 million. And then there is the 100 million. Only a couple of them are 100 million. So we are in this range. We are in the zone between 10 raised to the power of 7 and all the way to 10 raised to the power of 8. 10 through 100. We're somewhere here. So we should be safe. Preparing the model. $300,000 updates, and I think each time they update they have like a million tokens or something. That would give us what? 300 billion tokens. Being used to train the big model. Training sentences. We divide the language pairs into those with more than 9 million, those with fewer than 9 million. Those are some numbers we've observed ourselves. Okay. We'll see what makes sense. I'm gonna leave this task for a bit later. Let's try and run the LID for QED dataset just to see what we get as a result. So let me open up the example YAML. Where is the example YAML? Okay, here it is. So in this config, we are currently using what? Length filter. And we need to add the LID filter with default threshold of 0.01 at the moment. Additionally, we need to just scope down to the QED dataset. LID filter, length filter. Included corpora. Okay, let's quickly exclude everything except for QED. And see how we behave on that data set. Okay, going to LID. We will be writing to this output file called LID filtered sentences. Let's try and run this and see whether we observe any failures. Okay, let it just run. Okay, this is very low quality data. Okay, there is definitely some text that's completely off. Looks like Hindi script or something. So again, the LID, because the threshold is so low, we grab the probability for the source language, and if it's smaller than the threshold, that's when we filter out. And we have a very low threshold, 0.01. So it's like very low probability that source is English, or very low probability that the target is Serbian Cyrillic. In that case, we pick up that sentence. Okay, it looks like we are done. I was expecting to see some German. Or Turkish. Okay. I think we need to add some heuristics. Can we wrap up a sec? I'm not sure. Hi, Yosef. I'm not sure what you're referring to. We are working on the filtering pipeline for the Croatian, Bosnian, and Serbian. And I'm just refining and testing certain filters. Right now, I'm trying to test a language identification filter, which is supposed to filter out the languages which shouldn't be in our data. So we just need to have source and target language. In our case, source is English, target is either Croatian or Bosnian or Serbian. Let me know if that makes sense. Yeah, no worries. Okay, LID. So instead of picking up the probability, let me see. What's the highest probability? If the highest probability is like German, in that case, we're almost certainly, that's almost certainly gonna be correct, because that's a high resource language and German is very, very accurate. The LID is very accurate for German, for example. So let's test that. How can we do that? Let's put a breakpoint here. And let's run the filter again. So kick up the filtering job and put the breakpoint in the LID code. And let's see what we get as the output here. Okay, I think we have to delete some of these temporary jobs, like this one. This output directory has to be deleted, otherwise it's doing some caching stuff and it's not running because of that. Okay, here we are. Here are the languages. So German. What's the code for German? Okay, Deutsch. So DEU. Let's see if let's try and get German Latin script. Okay. So Deutsch Latin. And let's do the same thing for here. And we can do something like if source German bigger than, if any of these two are bigger than 0.5, in that case we filter them out. LED threshold and save this. Let's maybe comment out the regular code and just focus on German. Let's see what we'll end up with here. Okay, run. Okay. So if any one of those two is bigger than 0.5, and same for Turkish. Let me open up the QED dataset. Okay, here it is. Okay, this is not exactly German, but aha, my mistake here. Rerun again. Let me first delete the output here and kick off the filtering run while we simultaneously go through the QED dataset looking for non-Serbian language. This is actually fairly clean. We might need to play with different directions to stumble across the issues I've seen before. So if we go with Latin, I think we should see German here. Huh. Not good. This language ID detectors are super bad. Let's just remove the breakpoint. Okay, let me quickly see the notes we have on QED. I've seen some English and Turkish sentences in Bosnian. Use LID to filter this. So maybe we can test on Bosnian. English side this time has Serbian Cyrillic. Okay, nothing special here. Let's try Bosnian quickly. So remove this. Go to directions and instead include Bosnian, QED, and that's all. So let's try this. And Turkish as well. What's the code for Turkish? Turkish is TUR. Okay, again. Why is this? Didn't I change that before? Okay. Run again. I wish any of these components are super reliable. We 100% need to train a custom LID. Okay, that was quick. Okay, it did capture one sentence in German. That's not that great. Let's try maybe reduce this to like, I don't know, 0.1 and rerun. Okay, this time. Wait. How can it be empty unless... Yeah, we probably have to delete this again. Let's start. Okay, run it. Okay. This is definitely not German. Let's see Turkish. And let's put 0.5 here as well. Delete this. Kick it off. Let's see where we capture some Turkish. Okay. There is some Turkish in here. Okay, there is definitely some Turkish in here. Not super accurate though. There is a ton of false positives. Or actually, no, actually it's actually fairly good. I'm just looking at the source part of the pair. Most of these are Turkish indeed. Okay. Okay, so we definitely can add some heuristics that would help us. I'm gonna comment out this now and uncomment this. Increase this threshold to 0.5. So if the probability for the source or target language is smaller than 0.5, which we know is the ground truth, then we save that data. Okay, let's see what we get as a consequence. What's going on? Where did I mess up? Yeah, we did capture a ton of Turkish. Let's increase this a bit, like 0.9. We run again. Okay, so trying to see what we get with the LID filtering on the Bosnian, English to Bosnian language pair for the QED dataset. Let's see what we capture. So there is a ton of Turkish here, but there is also a ton of false positives because this is indeed Bosnian. Some English, English, okay. I didn't get any special insights for QED. There is some Turkish, there is some German. Ultimately, the best solution is to just train an actual LID system as opposed to hard coding all these rules. Let's switch the attention to filtering out the dates and sentences and the numbers from mined datasets. So to do that, we have to add an additional filter, which I just previously created. And delete this. And that filter is stored here. So if we find a date inside of the sentence, either target or source, we filter out that pair completely. Okay, so now that we have that, let's instantiate that filter, but we should only be using that filter when we're dealing with mined dataset. So because of that, I'm going to create a variable called extra filters, and that's going to be also a list. We'll also have instantiate, and we're going to call config. We're going to call what? Think for a second. I'm going to call it just mined filter for now. We have to update the config so as to support the new filter. Okay. Mined filter, and then I think that's it. There are no special arguments there to be made. Let me just double check that. So if we go to mined, yeah, nothing special going on here. So if we don't do anything, if we don't specify it here, in that case, we'll use the default value. We just comment out the LID. So everything will be null, except for symbols and mined filter. Okay. Go back here. So now we have the extra filters. So now we have to decide when do we activate it, and the answer is when we hit the mined dataset, and we can infer that through the corpus name, I guess. Let's see. Let's run this. Aha. We did not expose it in the init file. Stops, pipelines, filtering, filters, mind filter. Kick it off again. Why are you complaining? Okay. Should this work now? Let's go. Nice. Okay. So corpus name, data set. Okay, so we need to create a list of corpus names, which are of the mind type, as opposed to primary or back translated. Group name frame primary. Well, ideally, I'm kind of butchering this because we should be grouping Okay, let me create a hacky solution first. And then the correct solution will be to specify the group name will contain, it will tell us when we are dealing with primary data versus mind data. So the correct solution would be to its group name, infer which data sets are mind. But for now, I'm going to create a temporary dictionary that contains mind corpora as a simple list, and we just ask if corpus name is in that corpora, and if it is, then we can add the filter. It's going to be the hacky solution, just to test the filter, and then we can later implement it properly. So what are the mind data set? Which ones have been mined? To answer that question, let's go up here. Is there any simple way to know what's mined? Okay, I think this is mined. NLLB is definitely mined. CC align is also mined. Excellent is also mined. Wikimetric is mined as well. And then everything else here yeah, everything else is probably not even mined. Let's go to the Opus data set. website. Let's grab like English. And let's grab Croatian. HR. So here comes the list. Unfortunately, there is no mention about mining. We have to open them up explicitly. Mining. Okay, so let's see. Let's quickly open up all of these. Terracrawl is also mined. Fairly sure this is also mined. Yeah. Terracrawl is mined as well. Oops. Terracrawl. This is also mined. Same here. Okay, let's continue. Your pet. Let's continue with the other data sets here. Okay, this is how I suspected. Okay, this is actually mine, as in actual miners, as a job, as a profession. Let's continue. Couple more. Okay. So now let me just open up the CC matrix. CC matrix, and let's open up NLLB and actually CC aligned. CC aligned, and let's open up XLent. And let's open up Paracrawl and Wiki Matrix. Okay, Wiki Matrix. And let's just make sure these actually have mining mentioned. Yes. 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 Okay, this one does not mention mining. So we might make some mistakes, but I think for the most part we are safe. We've assumed these are the mine data sets, so we can just add these in here. Okay. Let's check out Serbian. I don't think there's any significant difference. Let's first go to Bosnian. BS or BOS. BS is Bosnian. Okay, NLLB, open subtitles, wiki, cancel. All of these are repeating. Is this a new one? This looks like a new dataset. Okay. And then for Serbian, Serbo-Croatian, okay, same datasets all over again. Gourmet maybe is a new one. Bible, Global Voices. Okay, all good, that's all. So now we say the following. And there's going to be a ton of refactoring I'll have to do after this, but bear with me. So if corpus name, let me think. Filters. We just want to do the following. Plus. Exactly. If corpus name is in mind, we add the extra filters, otherwise we do not. And the extra filters are again mining. Removing the dates in the sentences. So I'm gonna stop this now. Open up the exact the example YAML. Split it on the side here. So we're gonna use length, symbol filters, and finally dates. Okay, for the time being, symbols is just a no-op. It doesn't do anything smart. We can even comment out this. Okay. With this, I'm gonna put a breakpoint here and run this. Kick off our run, but before that, we'll actually have to change directions. So yeah, we can still use Serbian because it's smaller, and we can just comment out everything here, and now we should be good to go. Okay, running. And here we are. Until we find okay. let's now save and see what we are filtering out, and maybe we can refine it a bit so that if they're actually the same, if the dates are the same in source and target, then we actually keep them. So we don't want to necessarily filter out everything, but like in general, for mine datasets, dates are usually not correctly translated. They look roughly the same, but they are usually not correct. So that's the issue. Okay. So if we find date, in that case, we're gonna save that here. Okay, guys, this is it. This is it. I'm gonna kick up the run and see what we end up with. There's gonna be a ton of results. Aha, I think I might have made a mistake. Let me see. No, I did not. Here's the dates. Okay, so as you can see, we're filtering out a ton of these sentences that have dates inside of them. And not all of them are incorrect. Actually, these results actually seem fairly good. So that's why we should not be filtering out indiscriminately. We have to actually check that there is a mismatch. All of these seem correct. Okay, maybe here is one of the incorrect ones. And here as well. Because mostly they just resemble each other, but they are not really the same. Same here. So dates should be oftentimes incorrect. Same here. They kind of look the same, but not quite. And here. Okay. Go back here. Let me just ask ChatGPT a couple of questions. What is the difference between find all and search in regex package Python? is it safe to assume that find all is basically implemented as a successive application of search function? Fair enough. I think that's what I expected as well. There is always the danger of anchor bias, but so if this is find all put the breakpoint there and run the filter again. Okay. If they're the same in length, then there is a chance that we might do something like okay, and if they are different, in that case we break. Let me think what I'm trying to accomplish here. So what I'm trying to accomplish is only if there is any mismatch. So if they are the same length and all of the matches are the same, in that case we don't want to filter out. We can always achieve that using a simple flag. Will this work? Let me see whether the logic is faulty. So we go through the patterns, we find the matches. If either one of those exists, then we enter, we assume they are matched properly, Wait, this doesn't make sense. Wait. As I said, I'm going to refactor this later, but for now I'm just going to just hack it and make sure it works. So, if they are not matched, we want to filter it out. So if it's not matched, we want to filter it out. If any one of them exists, we want to enter the if statement, the if branch, and then if there is any mismatch, we say there is a mismatch. Does this make sense? I'm sure this can be written in a much neater way than what I've done. So again, go through the patterns, find all of the matches. If there are some matches on either source or target side, we enter and we assume that we have a match. If the lengths differ, then we definitely don't have the match. If they are the same, then we go through the matches, and if there is any difference, there is no match. And so if there is no match, in that case, we want to filter out that sentence. And that repeats for each of the patterns. I think this is legit now. Okay. So let's go and remove this. Save this and run the filter. Job, kick it off. Oh my god, this is going to be a bit harder than I thought. Obviously, there's going to be some differences in the languages. We'd have to parse the dates. So we'd have to parse the dates. There's so many ways you can write, you can have a correct translation. This is gonna be hopeless. There's too many ways you can have correct translation. So if we can just be dumb and just exclude all the dates. So this is the implementation that does that. So if we find any of the patterns, we just delete that sentence. Okay. I think this is a good enough implementation for now. And also numbers. if there are any numbers, we filter it out. So we can treat this completely uniformly. We don't need to create two special cases, so all of those patterns can be just checked. So if any of those patterns exist, we just filter out. So it can be a number or a date. And by doing that, we've accomplished this task here. We've done that. And let's just see whether it works. Again, clear this up, run the filter.py. This is going to filter out a ton of content. That much is certain. As you can see, this is why we are filtering it out, because oftentimes it looks similar, but not quite. Seeing here. Same here. It's hard for mining to have exact match. We can be a bit smarter. With numbers, it might be easier. Although there also might be some differences in how you represent a number in different languages. So you might have like some dot notation or something. Like do you write down a million like this or like this? The simplest way is to just be indiscriminate and just filter out everything. And that's what we've done. Okay, I'm going to stop this. We have to refactor the code, implement fuzzy deduplication, and we're getting closer to kicking off the final filtering run. Iteration number 1 is going to produce a single checkpoint. And then in the next iteration, we can improve many of the things and then create a better checkpoint. Once we have a checkpoint that's decently working, we can host it somewhere so people in the server can play with it. Like a Discord, as I said before, something similar to what Midjourney has been doing. We can have something like that, some bot inside of the Discord server. Okay, let's refactor stuff. Let me see whether I have any changes in FairSec, and then we can go to Stokes. Let's first start with FairSec. I think I have less changes there. TMP fuzzy. Okay, the easiest thing to do this is to just do diff tool. Let me before that just see data temporary fuzzy. Okay, this can definitely be deleted. Similarly to this one, because we have already implemented this. We have the same logic inside of the Stokes repo, so I'm gonna delete this. This one as well. Okay, this is the toxicity list. I'm going to quickly delete the old ones because we've updated this since this morning. So I'm gonna open this up. I'm gonna grab Bosnian, grab English, Croatian, and Serbian. I'm gonna copy those, go back here, delete this one, zip this one, and then just pick it up. Okay, and just like that, we've stored the latest changes there. Let's go back here. What do we want to commit? All of this can be ignored. Analyze lines. All of this can be ignored. I think we can just remove all of those. Let me just double check. There is nothing that can be deleted accidentally. I don't think so. Looking good. Yeah, we can remove the. Okay, let's just leave this be. This is all good. YAML. Okay, there are no changes except for the analyzed data. So let's just see what's going on in the analyzed data. What changes did I make? Okay, just some local stuff that's not relevant, so we don't need to push that. So that's it. That's that part. Let's now go to SOAPs. So for SOAPs, it's going to be a bit more work. These two. Okay, let's start with configs and filter. Configs. Show me the diff. Okay, so I've added a couple of new configs. So the mind filter, the symbols filter, and the fuzzy dedupe filter. Okay, this will definitely take some work. Okay, we can leave this as it is. Symbols, fuzzy. YouTube should not be optional, or okay, let's just make everything optional. Makes it a bit easier to test stuff. But we added symbols, fuzzy, and mind. Laser length, LID. Laser length symbols, LID toxicity, and then goes fuzzy, dedupe, and fuzzy. And finally, mind. Okay. So we have default values. By default, if you don't specify them, I think if we don't specify them, they should be, so the optional ones are none. Otherwise we specify. So those which are optional should be none. What's a good solution here? Let me think for a second. Okay. I think it's easier for me to just leave the constructors as opposed to having none. I want some consistency here. I'm just going to specify each and every one of them. And then it's your obligation, it's your responsibility to modify the example YAML such that you have the correct settings. Okay, looking good. What do we change here? Okay, I added a symbols filter, I added the fuzzy, the mind, some hackiness, and this is going to be a mess for fuzzy duplication. Okay, there's a, as I said, there's going to be a lot of refactoring here and consolidating the changes I've introduced. Kind of hacky, but it works. This one. Okay. As I said, this also needs to be changed such that we are creating as a part of a different group. We should be passing in. Okay, let's handle that potentially as the next step. So filter direction is called in here with a particular group name, and filter group is called with a particular group name, and group name goes through these, and we get the configs. Okay, fair enough. So what we would need to do is have a bit different include corpora for train mind versus train primary. That's going to be the right solution. But in all honesty, let me think what actually makes more sense from the standpoint of what's easier to do here. Nah, I think it's definitely cleaner to split stuff up here. So that means that we need to do the following. Have all this duplicated right here. And have included corpora primary, included corpora mind, Okay, so here we want to create a split. So that we need to know what's mind and what's primary. Huh. So we open up the train primary. We build up this direction and number of sentences, and then we dump the directions, and we save all different corpora names. Okay, does train primary, well wait, train primary, it would be hacky to have train primary being split into primary in mind. So we actually have to have two different ones here as well. Populate data config, train mind, so we need to split the data sets into mind data sets and primary data sets. Okay. So again, so I'm trying to modify something and now it's trickling down all the way to the data set. So I now have to go to PearSec. Here's our HBS data. And what we need to do is maybe this time manually. I'll open it up and I'm gonna create two different folders here. Primary, mind. And then I'm gonna grab go to soaps, filter, find the CC aligned. Okay, here are the mind ones. So grab the CC aligned, CC matrix, excellent, wiki matrix, NLLB, and paracrawl. And cut them and move them to mind. And then grab everything else except for the mind. Whoops. Except for the mind and primary. Copy those and paste those into primary. Okay. So now I have to do this manually. Ideally, we would have our download scripts do this automatically for us. But okay, let's go step by step. So now that we have this, I can point populate data config script. Let me go to the launch JSON. Populate data config, primary train root, HBS data / primary. And then we have mind data root. And we go to launch JSON. Exactly. And finally, we can now run this. The only difference is I don't think we should be calling get mind datasets here. Nothing changes really. So I think we just have to rename this. I'm gonna deprecate this. Instead, we just need to use the get primary. We can just rename this to get primary and mind datasets. And just go here and just do it like this. Okay. So let's now try and run this. Run this code with the right config. Kick it off. F5. Nice. So let's see now. We have train primary here. And we have train mind. And if we do, where is it? I don't see it, so maybe it might be just, no, there's some difference here. Where do we store one versus the other one? Data path. Aha. We have to change the data type. And we have to now go and run for the mind one. Okay. So now we have both the mind Okay, this looks good. Looking good. And now we need to split included corpora. Okay, let's go back to the scripts down there. This now needs to change. I'll just create a for loop here, and we're gonna use both the train primary and train mind, and we'll end up with directions and different corpora. Do we want to have two different directions? I doubt that's what we want. So let's go back to the example YAML. When it comes to directions, we just pass directions inside of here. Okay. Directions should contain the union of the directions between mind and primary, because those two classes of data don't have to necessarily be the same. Maybe we don't have mind supported for each of the directions. Let's see. So we maybe want to have a list. Something along those lines. And then we want to do like a for loop. And then we want to do like this. Let's just remove this one for now. If it does not exist, fair enough. And then we open it up, we'll load. We go through directions and data sets. Okay, so we get now for directions, we have the exact number of lines. And now we end up with this. Okay, so we will want to so corpora will need to be separate. Maybe let's grab the suffix here. So suffix will be split on the dot, grab the 0, then split on the, and grab the last one. That's going to give us primary or mind as the suffix. And then we can have F string here, something like this. And that's where we dump the included. Okay, this is good. This part makes sense. This part makes sense. The part that does not make sense is the directions. We want to store this at the very end outside of the loop, because we want to create a union. So something like this. And we will need to do what? Let's see how its directions used precisely. In the filter pipeline, directions is used here. We load all directions, we grab the keys, and then we go through the directions. What happens if we go to filter group, if direction is not in here, then we skip. Otherwise, we specify the direction and group name. So like primary or mind with a particular direction. But what if that direction does not exist for that group? Okay, I think we can handle this tomorrow. I'm already super tired. Plus, like, I can't get this, I have this injury of my shoulder, which is causing me a lot of pain and lack of sleep. That's why I look tired. If I look tired, I guess I do. That's mostly because my shoulder is messed up completely. So I have to go to like magnetic resonance on Monday just to see what's going on. I might have ripped some tendon or muscle or something. But yeah, anyhow. Okay, guys, that's it for today. We've done a ton of work, starting with the toxicity list this morning, fuzzy duplication, all of these different types of filters like symbol filtering, like hashtags. A ton of cool stuff has been done, and some refactoring tonight as well. So that's it. Tomorrow we're gonna continue with the refactoring. We're gonna continue with the fuzzy dedupe, because we have to create these equivalence classes before we can keep only a single candidate and remove all of the other fuzzy duplicates. All of that's going to be done tomorrow, and hopefully by the end of the day tomorrow, we kick off a filtering job so that we can have, in 2 days, we can have the data ready to start training our very first model for HBS data. That's the plan, guys. Okay. Anyhow, wrapping it up. Have a good night. Have a good day. Have a good morning wherever you are, and catch you tomorrow, roughly 10:30 a.m. Central European time. That's the plan. Okay, guys. Cheers. See ya tomorrow.